Hi, in question number 1, we need to integrate 2 divided by 3x cubed minus 1 upon 2 x to the power of 3 plus 5 with respect to x. Before we start with integration, we need to understand what is meant by integration. So when we are given a function fx and we differentiate it with respect to x, we get the gradient function, which means given any coordinate, if I plug in that coordinate into the gradient function, I can obtain the gradient of the function at that particular point. Now, conversely, if I'm given the gradient function and from the gradient function I need to come to my original function, which was f of x, then I need to integrate the gradient function. So here we are doing the same. We are integrating to find the original function fx. Now, when we integrate, we need to add 1 to the power of x or the variable and divide by the new power. Alright, so let's begin. Our question is written here. Now, the first thing that we need to know is that whenever we have to integrate, our variables must not be in the denominator. So, first we will rewrite our question as 2 by 3 x cubed minus 1 by 2 x to the power of negative 3 plus 5 with respect to x. Okay, so now we'll move on with adding 1 to every power of x and then dividing by the new power of x. So, adding 1 to the power, we get x to the power of 4 and divide by the new power. Then minus half written as it is. Adding 1 to the power, we get negative 2 and dividing by the new power. Adding 1 to the power and dividing by the new power and the constant of integration. So now let's simplify by multiplying. We can also cancel some common factors. 2 ones are 2 twos are. So here we have x to the power of 4 divided by 6, and in the second term we have negative 2 multiplied by negative half, which will give us positive 1/4 with x to the power of negative 2 plus 5x and plus the constant of integration. We can rewrite this as 1 upon 6 x to the power of 4 plus 1 upon 4 x squared. So when the negative x squared was moved to the denominator, it became positive x squared plus 5x plus c, and that's a final answer for this question. Moving on with question number 2, we have 3 to the power of x divided by 3 to the power of 4y is equal to 27 root 3. And the question says find y as a simplified function of x. Now let us observe the left side of our equation. So if we observe, we have the same base over a power. So our same base is 3 in the numerator and 3 in the denominator. And if we see here on the right hand side, we have the rule which explains when we have a to the power of m divided by a to the power of n, which means when bases are the same and they are divided, then the powers are subtracted. So we will follow the same. We have the same base 3 to the power of x, which is dividing 3 to the power of 4y, and it gives 27 root 3. So we will subtract the powers 3 to the power of x minus 4y. On the right hand side, we should be able to observe that 27 is equal to 3 times 3 times 3. So we need to rewrite 27 as 3 to the power of 3. Next we have square root of 3. So square root of any number is equal to that number to the power of half. So keeping that in mind, we will rewrite 3 to the power of half. Now our left hand side is already having the power, which is an expression. Let's write the power on the right hand, 3 plus half. So we have 3 to the power of x minus 4y is equal to 3 to the power of 7 by 2. Now the rule is when the bases are the same, the powers can be equated. So since we have the same base here, on the left hand side our base is 3 and on the right hand side our base is 3 as well. Therefore we can equate the powers and we can write x minus 4y is equal to 7 by 2. Now since we have to express y in terms of x, which means y has to be alone on one side of equation. So we have the term containing y with a negative sign. We will transpose it on the right hand side so the term becomes positive. So we have x minus 7 by 2 is equal to 4y. In this step, we also transpose this 7 by 2 from the right hand side to the left hand side. Now we see that we have a denominator 1. So we can multiply top and bottom by 2 to have a common denominator. Now we have 2x minus 7 divided by 2 is equal to 4y. Now the last step, all we need to do is to move the 4 to the other side. Now 4 is multiplied on the right hand side, so when it goes to the left hand side it will divide, and hence we have 2x minus 7 divided by 2 times 4 is equal to y, and we can rewrite a final answer as y is equal to 2x minus 7 divided by 8. Now here we can see that we have written y in terms of x. Alright? Question number 3. The line L1 has equation 3x plus 5y minus 7 is equal to 0. Find the gradient of L1. We already know if the equation of a line is given in the form of y is equal to mx plus c, then the coefficient of x, which is m, is the gradient of the line. We are now given 3x plus 5y minus 7 is equal to 0. We know that if we rewrite our equation in this form, then it will be very convenient for us to find its gradient. So we need to make y the subject of formula. We have 5y is equal to minus 3x plus 7. Therefore, y is equal to minus 3x plus 7 divided by 5, or y is equal to minus 3 by 5x plus 7 by 5. Now we know that the coefficient of x, which is negative 3 by 5, is the gradient of a line. So we write the gradient as negative 3 by 5. This is of course for the line L1. Alright, now we move to the part B of the question. So the part B says we have another line L2, and L2 is perpendicular to L1. So L2 is perpendicular to L1 and L2 passes through the point 6, negative 2. Find the equation of L2. So we need to find the equation of L2. Now whenever we need to find the equation of a line, we need to have two values. Y is equal to mx plus c is the general form of the equation of a line. If we know what is the gradient of the line and if we know what is the y-intercept, we can have the equation of the line. Now, we already have the gradient of line L1. Okay, so how does it help us to find the gradient of line L2? There is a special relationship between the gradient of two lines which are perpendicular to each other. So we know that the gradient of line L1 is negative 3/5. Therefore, gradient of line L2 is going to be 5/3. So the gradient of two perpendicular lines is the negative reciprocal of each other. Alright, so we already have the gradient. Now we have the point 6, negative 2 passing through L2. So we can write the equation y minus y1 is equal to m into x minus x1. And now we can plug in values that we know to find the equation of a line. So plugging in values, we know that the point that passes through the line L2 is 6, 2, 6, negative 2, and 6 is the x coordinate and negative 2 is the y coordinate. So we will plug in for y1 negative 2, so we have y minus 2. For m we will plug in 5/3, and for x1 we will plug in 6. Alright, so now we have y plus 2 is equal to 5/3 into x minus 6. We can take the 3 in the denominator on the right side and multiply it on the left hand side. So now we have 3 into y plus 2 is equal to 5 into x minus 6. We can open the brackets. 3y plus 6 is equal to 5x minus 30. 3y is equal to 5x minus 30 minus 6. Therefore 3y is equal to 5x minus 36. Now we can make y the subject. 5x minus 36 divided by 3. Therefore y is equal to 5x divided by 3 minus 36 divided by 3, and our final answer is 5/3x. We can cancel the 3 and the 36. 3 ones are 3, 3 12s are 36, and the answer is 5/3x minus 12.